In this example, we need to find the intervals on which the function is increasing and the intervals on which it's decreasing. And our function is -2 cos x minus x, and our interval of interest is from 0 to 2 pi inclusive. The first thing we need to do here is find our critical points. So how do we find critical points? We find the derivative of the function and set the derivative equal to 0. Let's take this term by term. Let's first find the derivative of the first term, -2 cos x. Well, the derivative of cosine of x is negative sine x. So we'd have -2 times negative sine x, which is just 2 times the sine of x. Now let's look at the second term, minus x. The derivative of minus x is -1. So the derivative of f is 2 sine of x minus 1. Now let's set the derivative equal to 0 and solve. Solving this equation will give us our critical points. To finish solving the equation, we need two angles between 0 and 2 pi inclusive that have a sine value of 1/2. Sine is positive in the first and second quadrant, so that's how we know we're going to have two solutions to this equation. The angle in the first quadrant that has a sine of 1/2 is pi over 6, and if we use that pi over 6 as our reference angle in the second quadrant, we find our second solution, which is 5 pi over 6. So pi over 6 and 5 pi over 6 are our critical points. Now remember, these are the candidates for local maxima and local minima. We still have to use the first derivative test to determine if they are local maxima or local minima. But that's not the focus of this problem. We just need to know where our function is increasing and where it's decreasing. So let's set up our x-axis, making sure that we begin when x equals 0 and end when x equals 2 pi, and also put our critical points on the x-axis as well. Placing our critical points on our x-axis divides our x-axis into 3 segments or 3 intervals. Let's find a test point or identify a test point in each of those intervals. And then we'll evaluate the derivative function at each one of those test points. If the result is a negative, that means that we're decreasing on that interval. If the result's a positive, that means we're increasing on that interval. Using Desmos Scientific to evaluate 2 sine of x minus 1, our derivative, at pi over 12, we get a negative value. That means that our original function is decreasing on the interval from 0 to pi over 6. Now evaluate the derivative at pi over 2. Evaluating the derivative at our test point of pi over 2 gives us a positive value. That means that our original function is increasing on the interval from pi over 6 to 5 pi over 6. Now let's do the same thing for our last test point, 7 pi over 6. Evaluate 7 pi over 6 at the derivative. When we do that, the result is negative. So that means that our original function is decreasing on the interval from 5 pi over 6 to 2 pi. So our original function f of x is increasing on the interval pi over 6 to 5 pi over 6 and decreasing on the intervals 0 to pi over 6 and 5 pi over 6 to 2 pi.